Hello, shall we start? Okay, good. So today I would like to show you a one rendering tree. At feenk we built some very cool user interfaces, and everything that we show on the screen is represented as a visual element. And all of those visual elements are part of one large scene graph, hence a single rendering tree. Now, in this talk, I'd like to show you a few examples, what we mean by that, how we make use of that, and how we manage to make it real. There are two challenges when it comes to making sure that we have one rendering tree. The first one is we should treat all layouts, no matter what, whether they are normal UI layouts such as grid, linear layout, or frame, and all visualization-based layouts like trees, force-based layout, they should behave and treated the same way. And the second challenge is to have a scalable text editor which is composed out of small visual elements. Here you can see a multiple editor, so it's functional, and it is built out of words, and each word is represented as a visual element. So in this case, I can change the color of each word, or I can resize, change the font size of each word. Now, I can still select words like a normal text editor, but when we start to represent every word as a visual element, we can also, for example, rotate each word. And it still continues to work in exactly the same way. Now, if we take a look at the little bit implementation detail of how this editor is composed, we can visualize it as a tree. And the root is the whole text editor, where leaves are those tiny visual elements. And notice that the cursor, in fact, it's not rendered. Cursor is just an element embedded in a text element. And to position cursor inside of this text element, between characters, we use just a special kind of layout, as linear, it's called cursor layout. And if I move the cursor, notice that it also moves from one text element to the other. Now, there is a tiny story behind this slide. I really wanted to make sure that text editor works, at least basic functionality. For example, when I click somewhere, the cursor should move, obviously. But how do we exemplify this? How can we test it? Of course, we can, for example, tell the editor model that, hey, I want a cursor to be moved to a different location, and we can assert that the location indeed changed. But how do we make sure that when I click visually, the cursor location changes in the model? For this, we need to know two values: the cursor location on the screen, and then cursor location in the model, which is represented as a text index. And when writing those tests or examples, it's really tricky to compute on a paper in your head where exactly the cursor should land. So in this case, we just changed the way multiple editor is rendered, and in this case, every character is an element. It still behaves exactly the same way as the normal editor. You can select multiple lines, but we also changed a little bit how the cursor is represented. Now it's an intersection of two lines, and we get a location of the cursor on the screen. And also on the bottom right corner of each character, we render the index in the text. So in this case, debugging this editor becomes quite trivial. Just look at two numbers, write an assertion, done. Now the next challenge, as I mentioned, is to be able to treat graphs and visualizations, especially their layouts, just as typical ones. In this case, we visualize some properties of spotter filters. And this is a tree visualization. And if I can expand each node, and it shows me editors. So in fact, this is a visualization in which we embed and can embed any type of visual element. In this case, it's an editor with selection and all the features. Now, I think this is one of the coolest slides of our demo. Here we show you a source code of example, which is in GT example, basically tested to return an object. And they can be composed. So we compose examples by sending an unary message. And notice that there is this dot. If I click on that dot, a new editor appears, which shows this yellow example. And the nice part of this, which I'm not sure if we have seen anywhere else, is that we can actually render a line that goes from inside of one editor to the outside of the other editor. And also, you probably cannot see, but there's also a typical arrow that connects outside of two editors. Now, because we connect with lines always two visual elements, we never connect some points, we always connect visual elements. And visual elements are quite powerful. They send events, which means when I scroll the editor, of course, the location of that dot changes in the window. So the line also moves. And notice that when I scroll down, the line disappears. And I do not think that without this property of one visual tree, one rendering tree, we can implement this kind of behavior as cheap as we can do in this case. Now, let's take a look how it's implemented internally. This is a representation of a rope. Rope is a data structure that is used to store text in multiple editor, and rope is a tree. A binary tree, to be precise. And on the right hand, you see the internal representation, how this tree is composed. And whenever I move my mouse over different nodes, you should see that on the right, the node is highlighted. And basically, in this tree, we highlight the path from the node behind my cursor to the root. So the whole visualization is basically composed of the elements, and the edges are also elements. Now, to achieve this, we had to treat graphical layouts as normal layouts. So now let's take a look at a class hierarchy of a geometry in Bloc. Now, geometry can be a circle, rectangle, triangle, and they are like SVG vector geometries. For this visualization, I use the normal, just grid layout. And then, because I want to position all those labels inside of the cell in the center, I have to set constraints. So we make sure that all layouts behave and are treated in the same way by introducing so-called constraints. The constraints are applied on each child, and the parent makes use of those child constraints to decide where to put those child elements. And in this case, because I know that the parent layout is a grid, then I just say that for a grid, you need to align all elements in the center, horizontally. If I take the exact same example, and simply change the layout from the grid to horizontal tree. And I will use, in this case, now graph constraints, and I will add edges, not visual edges, because we have distinction between visual edge and the edge, the logical edge. So in this case, now the class hierarchy is represented as a tree. And notice that we don't render the edges themselves. If we want to render edges themselves, what we do, we reuse the same example here, but we just add a visual edges in this case that are disconnected from the logical edges. And as a result, we get a visualization with lines. I mentioned that everything in our case is a visual element. Like everything is an object in Faro. In Bloc, a graphical framework behind Toolkit, everything is an element. In fact, even arrowheads are elements. So I can zoom in and notice, by the way, the colors are semi-transparent. So the clipping is really nice. Do you see this? This is some element embedded in the arrowhead of a curve. Let's zoom in. No way. This is the whole world embedded inside of the arrowhead in the curve. I mean, let's be honest, there is no real usefulness in that. But just by being able to achieve this, we can implement really crazy stuff. We can, for example, go to Bloc elements, inspect it, and get some documentation. Do you have any questions? Yes.
What are your thoughts about making this work on the web?
Making this work on the web. So Bloc has no idea how to render itself. So the rendering part of Bloc, this graphical framework, is actually packaged and shipped separately. So each Bloc element by default in its core doesn't know how to render itself. And the all rendering methods like draw on, they are extensions. So I believe that also the event loop, it's not in Bloc core itself. It's part of the windowing system, which is also shipped separately. In a nutshell, Bloc is a composition of elements. There is not much magic inside, and it's also shipped with the layout engine. I think that if we can render Bloc like as SVG and also make use of JavaScript events, propagate them to Bloc, we could make it work in the web. I think there was a question.
Why is the data structure called row?
Huh.
Sorry.
I couldn't find any like the reason why it's exactly called row. I couldn't actually find the text editor that, except this one, that uses row as a data structure. And I think the paper that describes row, it was written in the previous century, as far as I know. One of the issues with Rope is that it requires a language with a garbage collector. And implementing Rope data structure in C or C++ is very difficult. It's a challenging task. And I don't think that people actually tried it. But it works very well. That's it. Thank you.